Okay. So I think last lecture is screen visible to all. Is screen visible to all? So I think we have completed major losses, minor losses. Then we have got introduced about the Darcy-Weisbach batch equation, then Chedid's equation, then different kinds of minor losses, then some numericals, introductory type of numericals on minor losses. We have finished. Then last lecture, I think we have completed the hydraulic gradient line and total energy line. That kind of lines also we have completed. Now today we have to go for the new concept, that is new terms related to the pipeline connections. Then what are different kind of pipeline connections are there, and what are the properties of the pipeline connections. Then we are going to introduce about the equivalent pipe. One concept is there. Then siphon pipe, and then power transmission. So today we'll, if maximum possible, today we'll complete the theory of this chapter, and then we will move towards numericals. Maybe today afternoon, if I will get the lectures and I am means I don't have any other work, then we'll complete that also. So I think last lecture we have completed the hydraulic gradient line and total energy line. Okay, this we have finished. Last lecture, I think we have completed the hydraulic gradient line. So, what is hydraulic gradient line? Anybody of you? Anybody of you can define hydraulic gradient line? Hydraulic gradient line. Anybody of you can define? Nikita Pawar. Somebody. I want to. I request all of you to concentrate because this is a very important chapter as per the examination point of view.
It is sum of pressure head or bottom of flowing fluid of any pipe with respect to reference line.
Okay, what is that? It is total. Total.
Sum of pressure head or datum.
Pressure head and datum head. It is what? Pressure head and or not. It is not or. Sum of pressure head. It is nothing but sum of the pressure head plus sum of potential head with respect to any reference level or datum level. That is called as what? Here, that line joining the ordinates of pressure, all energy, which includes sum of pressure energy and datum energy at all points in a pipeline, is called as hydraulic gradient line. And the line which join the total energy means what? Pressure head, datum head, and kinetic head of a flowing fluid in a pipe with respect to reference line is called as total energy line. And we have know that total energy line is always above than the hydraulic gradient line. So this if it is a TEL, if you say TEL total energy line, then definitely below line is always what? HGL hydraulic gradient line. Okay, and always remember that difference in between these two lines is always anybody difference in between these two lines is always
V square by 2g.
2g means what? It is kinetic. Correct, very good. So it is difference is always equal to v square by 2g and is always equal to always kinetic head. Okay, so it is defined. Then if always total energy line is above, HGL is always below, and definitely when the flow it is towards outlet, all these two lines are decreasing or getting in declination type of nature. Okay, so this is another about the total energy line and hydraulic energy line. Okay, so with this now we'll go for the different pipeline connection. Now here write down different with me, write down the pipeline connections or pipeline connections, pipeline, pipeline connections. So very important. These connections are very important. We should understand. We should understand their properties also. So pipeline connections. So first pipeline connection is what? I don't know. Series pipe. Series pipe. When we say that pipes are in series, write down. First is what? Series pipe. Write down. When different pipes, so when different pipes, different pipes having different diameters, having different diameters, different pipes having different diameters, different pipes having different diameters, different pipes here having different diameters and lengths are connected connected end to end to end, then that type of that type of connect pipeline connection, that type of pipeline connection is called as is called as series pipeline. Is called as is called as series pipeline. Series pipe. Okay. Okay. So then, when different pipes having different diameters, sorry, different pipes are having different diameters. Okay, and lengths are connected end to end. In that type of pipeline connection is called as series pipeline. Now, suppose for example, let us consider this one pipe is there. Now, having this pipe having length L1. Okay. So whatever fluid is flowing through this pipe is having velocity V1, and whatever the diameter of this pipe is D1. So if this pipe, and if let us consider that this pipe is made up of some material, and that material is having coefficient of friction as F1. Okay. Now these pipe we have connected to another pipe. Let us consider another pipe is also having length L2, diameter velocity in that pipe will be V2, and diameter is what? D2. Okay. And this pipe is having another coefficient of friction F3. Let us this again is connected to another end to end. If it is connected to another third pipe, let us contact contraction connection. So having length is L3, velocity is V3, and diameter D3, and having the pipe coefficient of friction as a F3. Here it will be, sorry, here it will be F2. Okay. Now all these pipes are connected in series. So if the discharge flowing in them is different or same, anybody of you? Discharge flowing them through all these pipes, one, two, three, is different or same? Anybody of you? Discharge flowing through this pipe is will be same or different? Q is remaining. Anybody with remaining same? Everybody getting? So this pipeline connection is called as what? Series pipeline connection. What is that? These different pipes having different diameters. D1, here one pipe is having diameter D1, another pipe is having diameter D2, third pipe is having diameter D3. Lengths, one first pipe is having length L1, second pipe is having length L2, third pipe is having length L3, and their coefficient of frictions are different. Means they are made up of maybe same material or maybe different material, or they are having different kind of surface finishes. And if such kind of pipes are connected end to end, that is called as series pipeline connection. Anybody got this? What is meant by series pipeline connection? Please write in a message box. If doubts are there, please ask. So this is called as series pipeline connection. Anybody having objects, problem, doubt? Understood? Please write in message box at least. Yes, no. Fast, fast. Where? Hmm? And draw the diagram. Yes. Okay. Pramod, Shivani, Nikita. Okay. Okay. Draw this figure also. We have to draw. We have to go for some derivation. So L1, V1, D1. Okay. So series pipeline. Everybody got to draw this. Then, for property of series pipeline connections are write down. Discharge is same in each every pipe. So write down. Discharge is same. Discharge Discharge is same. Let us discharge is same. In each pipe. So first property of the parallel pipe is what? Discharge is same in each pipe. So therefore, Q is equal to, you can say, it is same, is equal to Q1 flowing in, let us consider in first pipe, flowing in second pipe is equal to flowing in third pipe. So this is the first property. Discharge is same in each pipe. And second, write down head loss. Write down total head loss. Total head loss is equal to is equal to total head loss is equal to sum of head losses sum of head losses occurs for each pipe. Sum of head losses occurs for each pipe. Let HF is equal to total head loss, okay, and is equal to HF1 head loss for pipe number 1 plus head loss for pipe number 2 plus head loss for pipe number 3. HF1 plus HF2 plus HF3. Everybody got? We are considering only minor losses. Sorry, only major losses. Considering right with me, considering only HF2 plus HF3. considering only minor losses, considering only major losses. Only what major losses, or I don't same shortly major losses only. Okay. Now, what is total HF? Now, only will consider. So, what is for first pipe? What will be the frictional head loss? Anybody? We're having diagram with us. So, having first pipe is having diameter d1, length v1, velocity v1, okay, and coefficient of friction f1. So, what will be the coefficient head loss for friction for pipe 1? Anybody? So we have to use Darcy-Weisbach equation for first pipe. Anybody of you? Nobody? Darcy-Weisbach equation, what is that? 4 is common. 4f1, coefficient of friction for pipe 1 is 4f1. L1 is the length, v1 square divided by 2gd1. It is the for first pipe head loss. Okay. Then for second pipe, now who will tell second pipe? 4 f2 L2 v2 square divided by 2g into 2. So parallel series pipeline consists what? Discharge is same in each pipe, but head losses are going to be different in different pipe depending on length, velocity, diameter, and coefficient of friction. But total head loss is equal to sum of head losses occurs for each pipe plus now 4. Anybody of you? 4f3 L3 v3 square divided by 2g d3. Okay. Then if coefficient, let us consider these pipes are of same material and they are having same finish, means their uh, coefficient of frictions will same. If coefficient of friction is same, for all pipes, okay, then this HF will be equal to, who will tell? 4 will be common, F will be common, so 4f upon 2g we can take common, where F is now coefficient of friction is same for all pipe, means F is equal to, in that case, only one coefficient for all pipes. F is equal to F1 is equal to F2 and is equal to F3. Okay, and 4f upon 2g divided by here L1 V1 square divided by D1 plus L2 V2 square divided by D2 plus L3 V3 square divided by D3. This is our equation. Everybody got this? Any doubt? So this will be the equation, that is total head loss. So for series pipeline connection, what is the equation? Discharge is remaining same for each and every pipe, and head total head loss is going to be different for different pipe, and total head loss is equal to sum of head losses occur for each pipe. Everybody understood? Please write down this. Plus tell me yes or not. If any doubt is there, please ask. Understood? Nikita, Shivani, others. Okay, Nikita Power. Yes, over. Okay, yes, over. Okay, good. Prathama is good. Now this we have only considered the. So you, this figure also you have to consider. So here only we have considered first here minor major losses. But if you consider, okay, if you consider major minor losses also there. If considering now here considering major or minor losses also. Minor losses means always we have to consider considering minor major loss always we have to consider considering minor losses also. Then total HL will write instead of HF will write here total HL is equal to head losses during the pipeline connection is equal to. Now you tell me first of all which head loss will occur, because if this pipe is connecting the two reservoirs. Let us consider this pipe is connecting two reservoirs. In that case, first option will be here anybody head loss at the entrance of the pipe, because if the pipeline now this is the one of the reservoir it is considered, okay, and this is first pipe is this pipe, okay, and second pipe is like this, and third pipe is again which one it is a contracted pipe. Okay, if these two reservoirs are there, this pipe number one, this pipe number two, this pipe number three, and these two reservoirs are connected to each other. First, when pipe one is there, when the liquid is coming into this particular pipe one, which head loss, first head loss will occur? Anybody of you?
Head loss due to entrance.
Head loss due to entrance. Very good. And it is equal to what is formula for that? So velocity in this pipe is what? V1. In this pipe velocity is what? V2. And in this pipe velocity is what? V3. So then who will tell first head loss at the entrance of the pipe? What is formula? Head loss at the entrance of the pipe. Anybody? Head loss at the entrance of the pipe is given by anybody of
0.5 V square by 2G.
okay 0.5, but V is replaced by here which is velocity in first pipe
V1.
V1 square. Okay, very good. 0.5 V1 square divided by 2G is first aid loss. Plus, always we have to consider minor losses as well as what? Always we have to consider major loss also. In first pipe, what is first major loss? 4 F1 L1 V1 square divided by 2G D1. Okay. Now, after we have considered now first minor loss, first major loss, then second minor loss will be. Nikita is doing understanding all. Others, please reply. Second minor loss will be first pipe and second pipe. What is done? What happened there?
Sudden enlargement.
Suddenly enlargement. Very good. And then second minor loss will come sudden enlargement. And what is the equation for sudden enlargement? What is an H enlargement is given by anybody of you? H enlargement is equal to V1 minus V2 bracket square divided by 2G. So first loss, yeah, second minor loss will come that day. Here it will be V1 minus V2 bracket square divided by 2G. Am I right, Nikita?
Yes, sir.
Okay. Plus another second pipe. What is major loss? It will be 4 F2 L2 V2 square divided by 2G T2. Okay. Plus continue. I am writing here. Plus now what will be first, third minor loss? This we have completed. We have completed this minor loss, major loss, again minor loss, major loss. Second last here. Second last minor loss will be anybody?
Sudden contraction.
Sudden contraction. Now it is given by equation. What is the equation for sudden contraction? Equation for sudden contraction, it is
Now, V3 square by 2G into bracket 1 upon CC minus 1
okay, but
bracket
this is not given. Then we are taking it as a 0.5,
0.5.
0.5. Which but velocity? Which is pipe velocity in that case? 0.5
V3
into V is V3 square divided by. Am I right na? 2G. The velocity in smaller pipe. In this case, which is smaller? Third pipe is smaller. Therefore, V3 square in zero point 0.5 V3 square divided by 2G plus 4 third pipes here 4F3 L3 V3 square divided by 2G 2G D3 plus now what will be last minor loss? Anybody? Nikita is telling all losses. Others please understand. All last loss will be okay. Nobody is ready other than Nikita. Okay, Nikita. Huh?
Head loss due to exit.
Exit. And what is formula for that?
V square by 2G.
But here in this case, V means
V4, no?
V3 only.
Sorry,
Exit
sir,
means
V3. V3.
V3 only. That pipe only. V3 square divided by 2G. So this will be the equation for the series pipeline connection. Okay. This is the equation for the series pipeline connection. Considering minor loss. Minor means we have to always consider major loss as well as minor loss. Understood? Please write message understood. Okay, yes. And then I will have to proceed for next. Okay. So Shivani Nani is giving answer yes. Okay. Diksha Dimile good. Nikita Power others boys front okay. Shubham Kandre yes. Okay, then write down this equation. 1 minute, I will give it to you. You came late or late? Wow, I'm going to say late applications. I'm going to say correct. Start with that. Correct. The person sanga. Considering minor losses also. All write down. I will give 1 or 2 minutes. If it is over, please tell over because we have to go fast. Please tell over, etc. Over. And if doubts are there, please ask. If it is over, over, over. Okay. Others, please reply. One. Okay. Over. Okay. Now another pipeline connection. Now we will go through book writer because I think it is writing on this board is very difficult for me. Okay, so this was the I think figure. So everybody, the first pipe is having this is the two reservoir. So this here L1 V1 D1. Okay, that diameter velocity and difference in between the two reservoir. That is total head loss will come is equal to H. I is equal to A. That is one equation is there. So total reservoir difference in between the two level of reservoirs, that is H, is equal to total loss occurs in the pipeline connection. The difference in liquid level surface is equal to, so this we have to also write afterward, remember. So difference in liquid surface level is equal to sum of the total head loss in the pipes. This equation is only everybody have to remember. So difference in liquid surface levels is equal to sum of total head loss in pipe. So difference in the liquid surface level is equal to capital H and is equal to sum of the head losses. So first of all, if minor losses are neglected, means only we have considered major losses. So minor loss neglected means what? Consider only major losses. Major losses only. Major losses only. Then is only F4 Fn F1 L1 V1 square divided by 2 GD1 plus 4 F2 L2 V2 square divided by 2 GD2 plus 4 F3 L3 V3 square divided by 2 GD3. And if this same equation we are getting. Okay. And if minor losses are also there here, difference in both H is equal to, here we can say H is equal to, okay, is equal to 0.5 V1 square divided by 2G plus first entry loss plus first major loss plus here second contraction loss, second major loss, third it is pipe is okay. Here instead of that our pipeline is little bit different. I have shown here like this we have shown. Okay, so here it will be expanded pipe is on my second pipe, and here this is different. So depending on the connection. Okay, so this is our connection, and their connection is expanded pipe, contracted, next is smaller pipe, and afterwards expanded pipe. Okay, so depending on that we have to write the equations. So understood? Now another pipe is there. It is called as what? Here equivalent pipe. Okay, so one concept now after series pipeline here we have to go for equivalent pipe. Equivalent, write down equivalent pipe. Equivalent pipe, write down. This is defined as this is defined as the pipe of uniform diameter, the pipe of uniform diameter having loss of head, having loss of head and discharge, having loss of head and discharge, disturb, having loss of head and discharge equal to head equal to discharge of a compounding pipe, discharge of a compounding pipe consisting of several pipes of different lengths and diameters, different lengths and diameter. The uniform diameter pipe, the uniform diameter of equivalent pipe is called as equivalent size, and length of equivalent pipe is equal to sum of lengths of compound pipe consisting of different pipes. Okay, so I will explain here. So you write down the definition. So if these three pipes are there, whatever three pipes are there, let us consider this first pipe, then second pipe. Okay, so this is called as what? Series pipe or compound pipe. See, another name for series pipe is also called as what? Compound pipe. Now these three pipes are there. I will here having different length L1, L2, L3, diameters D1, D2, and D3. So if these three pipes are there, and if you want to replace all these compound pipe or all the series pipes by only one size equal pipe, so that okay, only one size that pipe. But what is condition is there that whatever discharge flowing in series pipe or compound pipe should be equal to the discharge flowing in the equivalent that pipe, replaced pipe, and that replaced pipe, if this condition is satisfied, that is discharge in the series pipeline is equal to discharge in the our replaced only one uniform diameter pipe, so that pipe is called as equivalent pipe, or it is equivalent, we can say roughly it is equivalent to this compound pipe. And the diameter of this pipe, equivalent pipe, here is D. It is called as size of the equivalent pipe. And length of the equivalent pipe L is equal to, now let us consider D is the diameter of equivalent pipe and L is total length of equivalent pipe, is equal to what? Sum of the lengths, sum of the lengths for each pipe in the series pipeline connection. So L is equal to L2 is plus L3. In that case, it is what? Here L is equal to L1 plus L2 plus L3, and Q is remaining same in both cases. Everybody understand this concept of equivalent pipe? Please write message immediately yes, or if doubts are there, please ask. Don't waste time because we have to complete this fast. Message box fast, and write down the definition also. ऍडजस्ट केली थोडी दुपारी होती थोडं घेणारी अचानक घ्या म्हणली. Please write a message box fast. Nikita Pawar. If doubts are there, please ask Nikita Pawar, Shivani Nane, Admile, Shubham Singhan. Okay, Nikita Pawar, yes, over. Shubham Shivani Nane, yes, understood. Okay, Diksha Admile, yes, over. Others, please reply first. Shubham Singhan, yes, over. Others, please. Okay, now we have to derive one equation for this pipeline connection. Okay. Now I will use the same concentrate here. Now the head loss in the compound pipe neglecting minor losses is given by the head loss in compound pipe neglecting minor losses is given by. So H is equal to what? Let us consider H is equal to reservoir level. H is equal to 4 F1 L1 V1 square divided by 2G D1 plus 4 F2 L2 V2 square divided by 2G D2 plus 4 F3 L3 V3 square divided by 2G D3. Okay, assuming that all pipes are made up of only one material, same material, having same surface finish, then we will assume that coefficient of friction will be same for each pipe. In that case, what? F1 is equal to F2, coefficient of friction will be same for each pipe. Therefore, F first pipe coefficient of friction will be F1, second pipe coefficient of friction will be F2, third pipe coefficient of friction will be F3 and is equal to F. Okay, and discharge is also remaining same because series pipeline and here discharge is remaining same. Therefore, Q is equal to A1 V1 is equal to A2 V2 is equal to A3 V3 and is equal to what? Pi by 4 D1 square A1 which means is equal to pi by 4 D2 square V2 is equal to pi by 4 D3 square into V3 and this will give the equation for V1. So as Q1 is equal to what we can say? Q1 is equal to Q is equal to A1 V1. Okay. Therefore, V1 is equal to what we can say? Q upon A1. Okay. And is equal to what? V1 is equal to in that case Q upon A1 means pi by 4 D1 square. So this will become what? Therefore, V1 is equal to what? In that case, 4Q divided by pi D1 square. Okay. Similarly, V2 is equal to V2 is equal to 4Q divided by pi D2 square. V3 is equal to 4Q divided by pi D3 square. Now, substitute these values in this equation. Equation number 1, we can say it as equation number 1. Okay. Substitute value in equation number 1. What we get here? H is equal to 4F1 L1 4F1 L1 into V1 square in that case 4Q divided by pi D1 square its square plus 4FL2 4Q divided by pi D2 square divided pi D2 square its square plus 4F3 4FL3 4Q pi D2 pi D3 square its square now divided by D1 into 2G D1 2G D2 2G D3 then if you take common 4FL 4F divided by 2G. Okay, so this will become here also a simplification will give 4F. This will be 16Q square. Okay, 4F 16Q square divided by pi square is common and 2G is common. Pi square divided in the bracket. This will become L1. This L1 is not common. L1 divided by D1 raised to 5 because this is D1 raised to square seat square means d1 raised to 4 into 1 d1. So d1 raised to 5 plus L2 divided by d2 raised to 5 plus L3 divided by d3 raised to 5. So this is simplification. Okay. So head loss in each pipe equivalent pipe is equal to 4 equivalent pipes also. Now equivalent pipe is only one pipe and having what? Head loss is equal to total distance or total difference of surface level between two reservoirs. H is equal to what? In that case, is equal to, for equivalent pipe, let us consider 4 is the F is coefficient of friction only. F L only length of pipe L V square divided by 2GD, where what we can say, L is the length of pipe and D is the diameter of equivalent pipe. So is equal to what? H. Now, both head losses, according to our definition, head loss for series pipeline connection, this value, if this is given by equation 2, and here, if equivalent pipe is given by equation 3, then 2 and 3 should be equal. Okay. And in that case, what we can say, here H is equal to, again, V is equal to, in that case, we can put as a, V is equal to, here 4Q. Discharge is also same for equivalent pipe and series pipe. Here, because definition were written, discharge and head loss is going to be same, 4Q divided by pi d to d square only. Okay. So if you put in that case, we will get head loss for equivalent pipe is equal to 4 into 16Q square F divided by pi square into 2G into L by d raised to 5. Okay. Understood this page? And I have to simplify once again. Anybody of you problem, doubt, understanding this? Understand? Please write. Okay. Shivanyani, yes, over. Understand, over. Okay. Only Shivani Nani is giving answer. Understand, no. Others, please. Okay. Now here, head loss is going to be same. Therefore, we can equate these two equations here. So, I will write here equation once again so that for your understanding. H is equal to 4F L16 Q square divided by 2G. Okay. 4F16 Q square divided by pi square into 2G. Okay. Pi square into G into what? L1 upon D1 raised to 5 plus L2 upon D2 raised to 5 plus L3 upon D3 raised to 5. D3 raised to 5. Okay. is for compound pipeline, and H for only one uniform diameter pipe that we call it as equivalent pipe is equal to 4F 16 Q square divided by pi square into 2G into bracket we have said L upon D raised to 5. Okay. Now both as per definition, as per definition of equivalent pipe, what we can call as per definition, head loss is same for both pipe, equivalent pipe as well as compound pipe. Therefore, what we can say now here 4F, we can equate this equation. If we give a number 2 or something, the if number is at 2 and 3, we can equate. Okay, so if we can write here 4F 16 Q square divided by pi square into 2G is equal to, or sorry, into bracket L1 upon D1 raised to 5 plus L2 upon D2 raised to 5 plus L3 upon D3 raised to 5 is equal to 4F 16 Q square 4F 16 Q square divided by pi square into 2G, okay, into L upon D raised to 5. Okay, so in that case this 4F 16 square is going to be cancelled, and what we are getting now, therefore L upon D raised to 5, I'll write this term first, is equal to L1 upon D1 raised to 5 plus L2 upon, sir, L2 upon L2 D2 raised to 5 plus L3 upon D3 raised to 5. And this equation will give the relationship between length of equivalent pipe, diameter of equivalent pipe with the lengths of all series pipelines and diameters of series pipelines. And this equation is called as Dupit's equation. Is called as what? Dupit's equation. Is called as Dupit's equation. So this equation is used for determining the size and size. Generally, we know that length of equivalent pipe is equal to L is equal to L1 or lengths of sum of the lengths of all series pipeline connection. So this equation is called the Dupit's equation and is generally used in CVD may ask. Dupit's equation is used for determining the size of equivalent pipe. This is called as Dupit's equation. Everybody understand? Please write message box. Please write message. Okay. Nikita Power, yes. Dikshad Mili, yes. Only three girl students are responding. Other boys, please respond. And within 2 minutes, I will give you to. You can. Okay. Shubham Singhan, yes. Others, please reply. Ganesha Misra, yes. Okay. Good. This is called as equivalent. So write down. On within 2 minutes, everything you have to write. This is called as Dupit's equation. Okay, over one over good. Others please reply. Okay. So it is same L upon d raised to 5 L1 upon. So this simple example also will take on Dupit's equation. So write down numerical now. A simple numerical. Three pipes of, so hence this equation is called Dupit's equation. In this equation L is equal to L1 plus L2 plus L3 and D1, D2, D3 are the known. Hence equivalent size of L be obtained. Now next numerical write down. Three pipes of lengths, three pipes of lengths 800 mm, 500, sorry 800 meter, three pipes of lengths 800 meter, 500 meter and 400 meter are of diameters 500 mm, 400 mm and 300 mm respectively. They are connected in series. These pipes are have to be replaced by a single pipe of length 1700 meter, 1700 meter, fine diameter of single pipe. That is equivalent pipe. So L1 length of pipe is L1 800 meter, diameter D1 is equal to 500 mm is 0.5 meter. L2 second pipe 500 meter and diameter D2 400 mm is 0.4 meter. L3 400 meter and diameter D3 300 meter is 0.3 meter. And total length L is equal to what? L1 plus L2. It is always equal to or maybe different. So, yeah, L is equal to 800, 500, 400, say 100 meter. 700 meter. So as we know the equivalent Dupit's equation for equivalent pipe L upon D raised to 5 is equal to L1 upon D1 raised to 5 plus L2 upon D2 raised to 5 plus L3 upon D3 raised to 5. We can use and the equation will be D is equal to here say 371.3718 meter. Of course, it's converted into what? Mm. 371.8 meter mm. Everybody understand this numerical, simple numerical, but for that we should know the formula. Understand numerical, understand derivation, understand of equivalent pipe. Yes. Shivani, yes. Okay. Others please reply. Other boys please reply. Physical stock checking activity here for हे ऑर्डर बाकी टाइड कुलकर्णीला पण सांगा ते लागते त्यांच्यावर ते रिपोर्ट आलेले म्हणजे आपण ऑर्डर दिली आहे प्रमाणे तरी सॅम्पल रिपोर्ट सॅम्पल पाच वर्ष सध्या जर आपण 1-2 वर्षाचं तयार पहिलं ते रिपोर्ट आहेत बघा टायडेफिकेट असं नसेल तर मग करून घ्यावं लागेल काय काय गोष्टी ऑफिस सांगून करून घेतली मग पहिले ऑर्डर काढून करून घ्यायची okay then Next is flow through the parallel pipes. Understood first concept? So next concept is what? Here flow through parallel pipes. Flow through parallel pipes. What parallel pipes is there? So here what which pipe we can say that it is in parallel pipe? So when main pipe which is divides into two or more branches, and again he read this, don't copy this, write down this all. Consider a main pipe which divides into two or more branches and again join together downstream to form a single pipe. Then the branches pipe are said to be connected in parallel. Means if it is a main pipe is this ESQ, it is branched into two pipes. One is having Q2 having flowing discharge Q2 in first pipe. Let's say this first pipe having length L1, diameter D1 and velocity V1, and another pipe having length L2, diameter D2 and velocity V3. Again they joined as a one pipe. So that is called as what? Means these pipes are called as they are connected in parallel. Let us consider this as the first main pipe. Okay, it divided into here. Okay, discharge is flowing is Q, and here first pipe, this pipe is second pipe. This is pipe one, and again they form two flow discharge. Okay, so having diameter L, length is L1, diameter is D1, and velocity flowing in this pipe is V1, and this pipe length is L2, diameter is D2, and velocity is V2. Okay, and now what are the properties of parallel pipeline connection? Discharge flowing in main pipe is now divided into two discharges in this case. One is what? Flowing in first parallel pipe and another is flowing in second parallel pipe. So Q is equal to discharge is what? Total discharge is equal to sum of the discharges like here flowing in each pipe. Sum of the discharges flowing in each pipe. If it is the third pipe is there, then it will be Q is equal to Q1 plus Q2 plus Q3. And here it is two pipe, Q is equal to Q1 plus Q2. And but loss of head in for each for branch pipe 1 means loss of head is same for pipe all pipes. So loss of head is same, loss of head is same for all pipes. Loss of head is same, and but discharge in main pipe is equal to discharge flowing in each parallel pipe. If you understand this flow through pipe parallel pipes, understood flow through parallel pipes. Main pipe is divided into two or more branches, and if again reconnected rejoined as a one main pipe, then these pipes are branched pipes are called as pipes in parallel, and discharge through main pipe is increased by connecting parallel. So parallel pipeline connection is used for increasing the discharge. That also you have to remember. You have to understand parallel pipeline connection. नंतर lecture. Okay. Hello, understood? Yes, Shivannani, only Shivannani today. Nikita Power, Shivannani. Okay, others. Okay, Dikshad Mile, others. Please reply. Yes, over. Okay. Now, Now, now here we know that here Q, here parallel pipeline connection, this discharge is this pipeline diameter L1, velocity V1, diameter D1. Okay. Latest coefficient of friction will be F1. Discharge flowing in this pipe is Q. This pipe is Q2. Discharge is flowing is Q1. Again it will become Q. Okay. This will become Q2. Q2. Then this is VL2. Velocity is V2 and diameter is D2. Now we know that what we know for parallel pipe, Q is equal to Q1 plus Q2. Okay, so discharge is same, different, and main discharge is equal to sum of the discharge flowing in each parallel pipe. And then what we say, HF, head loss is HF1 is equal to HF2. Let us consider only major losses. Here I don't. Major losses only. So here means if it is 4 F1 L1 V1 square divided by 2G D1 is equal to 4 F2 L2 V2 square 2G D2. This 4, if F1 is equal to F2, if both pipes are made up of same material and having same coefficient of friction, then 4F1 2G, 4F2 2G will get cancelled, and then L1 V1 square divided by D1 is equal to L2 V2 square divided by D2. So with the help of these two, one can calculate the discharge flowing in each pipe. So this will be equation Q is equal to Q1 plus Q2, and L1 V1 square divided by D1 is equal to L2 V2 square divided by 2 D2. With the help of this equation, one can calculate the parameters of each parallel pipeline connection, means discharge flowing in each parallel pipe and velocity in each parallel pipe. Understood? Understood? Please write. And then complete write up also. So these are the properties of parallel pipeline connection. Okay, Balaji is good. Responding now. So parallel pipeline discharge is here. What we can say, discharge is going to be different in different pipeline connection, but head loss is going to be same. So these property, and series pipeline, what is the condition? Series pipeline connection, head loss is going to be sum of total head loss is equal to sum of head losses occurs in each pipe, and discharge is same. Series pipeline connection, here parallel pipes discharge is different, and it is equal to main discharge is equal to total discharge is equal to sum of the discharges flowing in each parallel pipe, and head losses for each parallel pipe is equal to same. And for series pipeline connection, here head losses is going to be addition of all the head losses, and discharge is same. Write down. If it is over, please tell me over. Okay, shall we proceed? Okay. Now, last article of this, or numerical will take afterwards. Power transmission through pipes. How much power is going to be transmitted through the pipes? Okay. So right, first take draw this diagram or consider this diagram. So this one reservoir is there. One reservoir, and this reservoir is connecting one pipeline. So one pipeline is there for this, which is transferring the water from this reservoir to any space. Okay. So if diameter is going to be d, diameter of this pipe is going to be d. L is going to be the length of pipe connected to this reservoir. Okay. And whatever the water or liquid fluid is flowing, this is having velocity v. And this reservoir, whatever the head available for the reservoir, the water is there or any fluid is there. So this h will be h. Now here the total head available at inlet is equal to what is total head available at inlet? This potential head only. Total head at inlet or total energy at inlet is equal to only potential energy, it is capital H, because it is not velocity will be in the reservoir is zero, a very less velocity is there, and pressure only atmospheric, and here also atmospheric pressure. So only head will be H, and head losses will be, let us consider HF, major head loss if you consider, head loss will be HF, only friction head loss will consider, head loss is equal to HF. Then what is net head available at outlet? Net head we can say at outlet. Anybody? If H is the total head at inlet, head loss at during the pipeline in the pipe is HF. And what is net head? काय H head होतं त्यातलं H थोडं लॉस मध्ये गेलं फ्रिक्शन मुळे तर HF. तर net head will be what? Anybody? Net head will be anybody? Or we say that H net is anybody? Nobody is giving answer. H net is equal to okay. H net is equal to what? H minus HF. So total head at inlet. So the head, okay, now we'll go for L is equal to length of pipe. So we'll not waste our time here. So L is equal to length of pipe, D is diameter of pipe, H is total head at available at inlet. Okay. Then V is velocity of flow in pipe, HF is head loss due to friction, and F is equal to coefficient of friction. Then the head available at outlet or is equal to what? If minor losses are neglected, total head at inlet minus lots of head due to friction. So it is equal to H net, we can say. H net is equal to H minus HF. Is equal to H minus HF is equal to H minus 4FL square divided by 2GD. 4FL square divided by 2GD. Okay. So H minus, okay. Now here total power. So directly will up to this everybody understand. So total power transmitted through pipeline is given by total power, total power, power transmitted through pipeline, power transmitted through pipe P is equal to is given by done only rho Q G into H net, rho Q G into H net. P is equal to what? So rho, this Q is velocity. This is the continued equation. We can see it as a rho into A1 or AV, rho into velocity in pipe, rho into area of pipe into velocity into G into H net is what? H minus HF. A is equal to, now we'll write power P is equal to is given by equation rho into pi by 4 d square into velocity into expression due to velocity G into H minus 4 F L V square divided by 2G D. Okay. So with the help of this equation, one can find, or if you take V inside bracket, so is equal to what? Rho into pi by 4 d square into G into bracket HV minus 4 F L V cube divided by 2G D. Okay. So with the help of this equation, one can calculate the power transmitted through the pipeline. Now we want to get the condition for maximum efficiency. Condition for max efficiency. What is the condition for maximum power transmission? Maximum power transmission or maximum efficiency. So for that, this power equation is depends on what? Rho, it is constant. Pi by 4 d square. Diameter of pipe is also constant. G is also going to be constant. Head at inlet, in power, head at inlet is the head at reservoir is also constant. F is constant, L constant, only it varies with respect to V. So we have to say that P varies with V. It only varies with velocity of pipe. Otherwise, everything is going to be what? So P varies with only V velocity. Other things will remaining constant. Rho, D, H, D, F, L. These are fixed parameters. These will not vary. Only variable parameter is what? Only V. Therefore, anything if you want to get maximization or minimization, condition is that in ATD we have learned steam nozzle or reciprocating compressor. Anybody book on whose memory is good? What we have done? If P varies with V, what we have to go for to get the maximization condition or minimization condition or optimization condition? Anybody, anybody, nobody. Okay. Then what I will tell. What is that condition? Differentiate that equation dP with respect to that variable dV and equate that differentiation equal to 0. Okay, as P is varying with V, what we have to do is there the power equation we have to differentiate with respect to V and we have to equate it to 0, and therefore dP by dV will become what? Rho pi by E is constant, pi by 4 d square G will be constant, so we'll take it as a outside bracket. What will be there here? Rho into pi by 4 d square into G is remaining as it is. Rho into pi by 4 d square into G as it is. Okay, into bracket now differentiation will be what? What will be differentiation? H into V differentiation will be anybody? Nobody is interacting now. झोपले का सगळे? H minus काय येणार आहे 4FL2GD is constant. 4FL2GD will be constant. V cubes the differentiation काय येणार? Anybody? Anybody? 4FL2GD as it is. Anybody? V cubes the differentiation 4FL divided by 2GD as it is into what? V cubes scanner 3V square and is equal to what? 0. Therefore, this will get cancelled. Therefore, this if we transfer this side, it will get 0. Therefore, it is equal to what? H minus this will become what? 3 into, we can write simplification 4 F L V square divided by 2GD. This is equal to what? 0. Okay, and therefore this will become HF only. So H is equal to what? 3 into HF, or frictional head loss should be equal to H by 3. So this is a condition for maximum power transmission. HF is equal to H by 3. Okay, now efficiency of power transmission. What is efficiency of power transmission? Efficiency of power transmission. Efficiency of power transmission काय असणार? H net ratio of net head available at outlet divided by head at inlet. It is that ratio. and therefore for maximum efficiency or A is equal to what? H net means H minus HF divided by H. And now maximum efficiency HF value will be H by 3. Maximum efficiency will be H minus H by 3 divided by H. And is equal to what? 2 by 3 and is equal to 0.66%. 0.6 or 66%. So efficiency of power transmission is coming as what? 66%. Everybody understand this? Please reply at least. Okay, Pramod, Aureka, yes. Yes, Diksha, Mili, yes. Okay, no problem. So everybody remember that efficiency of power transmission is given by ratio of net head available at outlet to the head available at inlet. Okay, and is equal to H minus HF by 3, and maximum efficiency HF we have to put it as a H by 3 and is equal to 0.66%. So maximum power transmission efficiency is 66% and is given by equation. One condition for that is frictional head loss should be equal to one third of the head at inlet. Okay, so this will be given HF is equal to, so little bit some norm here book terminology different. So HF is coming as here H by 3 and efficiency is coming as what? 66.7 or 66%. Everybody understand this? With this we'll stop. Shall we stop here? I will provide these notes to you. Okay, so this PPT I will provide to you. Okay, so with this I think we'll stop here. So I want attendance. Okay, so please give me attendance. Today's date is 17. If possible, I will take today afternoon lecture so that we'll finish this chapter section 1 today only by taking some numericals. Okay. So roll number 1.
Present, sir. Yes.
Okay. 2. 2. Roll number 2. Roll number 2. Roll number 2. Absent. 3. Roll number 3.